everyone. I'm Yvonne, a children's librarian here at the Manchester City Library, and welcome to Elementary Experiments. Here we will do experiments and activities aimed at elementary grades 1 through 6 with a focus on STEAM, or science, technology, engineering, math, or art. This fall, we are going to continue to have our in-person events at 3:30 p.m. on the second Wednesday and the fourth Tuesday of the month. We are going to actually be doing the same activity and craft on both days that month to hopefully allow everyone who would like to participate. We will be putting this video up at the beginning of the month so that anyone who is not able to come can still follow along, or if you want to get a sneak peek so that you can come later in the month, that's also an option. Remember, if you would like to join us in person, please visit our website to register to make sure that we have enough supplies for everyone. Any extra craft kits that we do have will be put out at the Children's Reference Desk so that you can take them home and follow along with this video. Now that that's all been covered, let's get into this month's elementary experiments. Hello and welcome to the September elementary experiments where we are going to be looking into sun power. With our activity and experiment, we are going to be looking at how the light of the sun, or specifically ultraviolet light, can affect things here on Earth. So ultraviolet light is actually part of the light spectrum that we as humans cannot see. It is visible to insects and birds, but not to us. Humans are actually only able to see a small portion of the middle of the light spectrum. There's actually spectrums of light that are lower in intensity called infrared, which you might have heard from like infrared cameras, which can be used to see things in the dark. And then there is the far end of the spectrum, which is the ultraviolet range. And that is when the light is a higher intensity. And that is the portion that we are going to be kind of looking into. Light from the sun, including UV radiation, actually does help humans in small doses. We need it to make vitamin D in our skin, which is important to keep us healthy. But as you might know, too much sun can cause damage to our skin in the form of a sunburn. And high doses of ultraviolet light or ultraviolet radiation can cause skin cancer as well in some extreme cases. This is why it's actually important to wear protection on your skin if you're going to be outside. Definitely if it's very sunny, but even if there is cloud cover, UV light can still go through. Remember that we cannot actually see UV light, so although it might look like there is no light coming through the clouds, there is still this ultraviolet light. Which can still give us sunburn. So if you're going to be outside for a long time, it's probably a good idea to use sunscreen, even if you might not think you do. That actually brings us into our very first activity. We are going to see how different sunscreens are able to protect our UV reactive beads from the sun. For this sun versus sunscreen experiment, you are going to need a bag of UV reactive beads. You actually don't need that many, but I have extras for when we all do this in person. You're going to need at least 2 different SPFs of sunscreen. I have one that is 30 and one that is 50 plus. It also is going to be important on whether or not your sunscreen is expired or not. So I would check this. You can actually set up your experiment a couple different ways. If you do have a bottle of expired sunscreen at home, that you can actually get one that is the same level of protection that is new, and then compare those. Or you can do 2 that are of different levels. So I have an SPF 30 and also an SPF 50. So SPF stands for sun protection factor and does not actually refer to how long that it will protect you. It actually refers to how much more solar radiation or UV light that the sunscreen can absorb before your skin is affected. It's really interesting. They actually do tests in the laboratory to get this number by exposing um, untreated skin to UV light and then timing to see how long it takes for a sunburn to start, and then applying the sunscreen and then testing that to see how long it takes for sunburn to start, and then using math to figure out how much longer, right? So an SPF 30 would allow you to stay out in the sun approximately 30 times longer, but more accurately, would allow you to absorb 30 times more of the UV in the sunlight before your skin is affected. This means that it does depend if the sun is very bright or directly above you. That's probably going to mean that you're absorbing it faster than if it is, a more mild day, as in like summer versus winter sunlight. There's a lot of factors involved, so you do want to be cautious if you are playing outside in the sunlight, and make sure to reapply your sunscreen without waiting the full amount of time that you think that it should be able to give you. All right, so that's kind of what these SPF numbers mean. But now let's test how well ours actually affect. We're going to actually do something similar to what they do in the laboratory to get these numbers. But instead of using our skin and getting sunburn, we are going to take some of our beads and these bags. I have 2 sunscreens. You can test more if you'd like. So I have 2 bags, one for each, that I am going to label. And then I also have an extra bag here, which is going to be my control. So a control in an experiment is something that you do not do anything to. So basically, we're going to label these. So here is my control bag. And we are going to put some beads in. So a control is something that we put in so that we can compare the things that we are testing, in this case our different sunblocks, to something that we have not done anything to, right? All right, so we're going to fill up all of our bags. All right, so we have all 3 of our bags. We have our control, we have SPF 30 and SPF 50. So now we have to add our variables, the things that we are testing, which is our sunblocks. So remember, the control, we do not put a variable with our control. It is there so that we can compare. So that's being put aside. Then we have our SPF 30. I'm going to take my bag. I have the writing on this side. I'm going to put that face down. So I have the clean side of the bag. So I'm going to take my sunblock and I am going to measure out a spoonful. Depending on the size of your bag, this is going to be more or less sunblock that you're going to use. So we're going to spread our sunblock all over the back of our bag, so it's completely covered. Honestly, I probably could have used less sunblock for this one, but here we are. Okay, so we've got our sunblock covered bag, and then we're going to let that dry. Then I am going to wash my hands so we don't have cross-contamination. Cross-contamination is if I were to try and spread my 50 plus with this finger that has my 30 on there, then they would be mixed together. And once we finish the experiment, we wouldn't know if it was the 30 or the 50 that had actually protected the sun beads from the sun. So I'm going to do a quick wash, and then we're going to repeat that with our other sunblock. Here we are with our 50. Again, I have my bag down so that the writing is on the bottom. So I am using the same amount of sunscreen, or as close as I can get, and that's again so that neither of our test subjects has an advantage, right? Because if we used way more of the 30 and then way less of the 50, then the 30 may be protected better. So we want an even or the same amount, and we want the same size bags and about the same number of beads to try and make everything as fair and even in our experiment as possible. Okay, so now I'm going to let these dry, and then I am going to take them outside if it is a sunny day, and put them in the sun with my control, and then kind of keep an eye on them to see if there is any change. So you don't want to leave them out there too long, because remember, even if you have a stronger sunscreen, eventually it will absorb as much of the UV light as it can, and it will affect the beads. So you want to leave them out maybe a minute or two, and then check on them. You want to probably take them in when at least one of the bags that has the sunscreen is starting to show change, or possibly wait until you can just see it on the second bag, but that's up to you. And then we are going to bring them back in, put them in order of most colorful to least colorful, and then see which of our sunscreens has protected our beads the most. If everything is as it should be, then our 50 should be the least colorful, and then our 30. But like I said, there are a lot of different factors. Like my 50 is still technically okay to use, but it is actually on its like very last month before it is going to be too old and is going to be expired. So it is possible that the 30 could do a better job. That's what we're here to experiment and then to figure out why we think these things happened, right? Okay, I will also say that if you do not have a sunny day, you can use something like a UV light or a black light. I have some flashlights here to simulate the sun. Remember how we said in laboratories in the testing to get these numbers, they do actually use UV lights because in the laboratory conditions, that's easier to control and know exactly how much energy they're putting out. So you can do this in your own experiment. You just want to make sure that that each of the bags is getting the same amount of light. So if you have like a large black light, you can do them at once. Or if you have only like one flashlight like I do here, you'd probably want to do one bag at a time and then set a timer and expose each one to the UV light for that same amount of time. At least that's my suggestion, but you guys are able to make up your own experiments as you go. All right, that's enough of me talking. I will put these out to dry and then expose them to UV light, and we'll meet up here afterwards. All right, hopefully I got these back inside fast enough for you to see color change, but I'm not sure. Here we are. Oh, now, okay, so we have had a lot of fading. They do change back clear fast, but we definitely had our control was basically all colored. I took a picture, so hopefully you guys will be able to see it better on that. But our control definitely was fully changed. And then our SPF 30 did actually perform in between. So the fact that my SPF 50 is on the verge of becoming expired still meant that it performed better than my sample of SPF 30. The results of this experiment for me did follow my hypothesis because I did think that the control was going to all turn, and then that there would be more colors in the SPF 30 than the SPF 50, and that did follow my expectations. So yes, I'm pleased with how this experiment turned out. Do be careful, because even though I did let my sunscreen dry for a little bit, because plastic does not absorb like skin, I did get it onto my tray. So just keep that in mind when you are taking them in and out and deciding where you're going to put these bags. I hope that you enjoyed, and I hope that you have learned a little bit about how powerful the sun is and what we can do to protect ourselves. All right, let me finish getting this cleaned up and then we will move on to our craft. Welcome to our craft portion of elementary experiments, where this month we are going to be working to make cyanotypes. So if you do have our craft kit and you open that up, you will find our instructions. You're going to find a envelope of clear plastic, and finally 2 pieces of pre-treated cyanotype paper. So there's going to be 2 sides. One's going to be sort of like a this greenish blue side, and then a white side. The greenish blue side is the one that is treated with the iron chemicals, or iron compound chemicals, that is going to change color. Now, because it does change color in UV light or sunlight, we definitely want to make sure that we keep these away from the sun and light until we actually do want to expose them. So you might want to sort of think about your composition before putting it onto your paper. But first, I just want to take a couple seconds to talk about cyanotype, which is really a cool and very early type of printing and early photography. So cyanotype, it refers to cyan, right, which is a color of blue that we still use in actual color printers to this day. And this was actually originally developed by Sir John Herschel in 1842. So this uses the same kind of ideas that film cameras use, by taking the shadows of things, right? So say a leaf, and putting it onto or in between the light source and the paper behind it, and then making an impression, right? In this case, cyanotypes really only do types of shadows. So it's going to be either white, which is anything that blocks the light behind it. It is going to end up being white in the finished product. Or if it's something that is like a little bit see-through, like a skeleton leaf, or just like a gauzy fabric, even maybe, those may turn out a lighter blue. These were actually also used to make the first blueprints. So if anyone has ever, if you've ever heard anyone being like, "Do you have a blueprint of this building?" This is how they actually made the first blueprints. And that's part of the reason why we have this plastic sleeve here, is because you can either use leaves like these ones I've collected, so things from nature, which a lot of people do use to make cyanotypes because they leave really nice impressions because they are pretty thin and easy to lay down and keep from moving on the paper, and they do make for like really lovely compositions. But if you're a little bit more interested in the blueprint side of it, what you can do is use this plastic sleeve and actually use a thick marker or a type of paint. You want it to be something that the light will not shine through. So something a little bit more durable than like than Crayola Magic Marker, because I think those are going to let too much light through. But if you have your pen and you want to draw something onto the surface, and then you take your paper and slide it in, whatever you will write on the surface here will actually be printed in white onto the paper after you put it in the sun, or at least hopefully if all goes well. And why this is so useful is because you can do the drawing once on this plastic, and then theoretically you could have a print, and then to make another print you would just take your next piece of paper, slide it in, expose it to the sun, and you would have an exact copy without having to redraw it several times, right? And that's one of the reasons why it was used for blueprints, is because it sped up the process so much before we had things like computers to do our printing for us. Then once you have everything arranged, you want to take them to a sunny spot and expose them to the sun so that they develop into the pictures that they are going to be, and become that really deep, lovely Prussian blue color. So this can take a varying amount of time depending on how much sunlight you have and how direct it is, right? So according to what I've read, it can take anywhere as short as 2 minutes, but it's probably going to be more like 5. And then if it's not very strong the sun, it can take up to a half hour or more. And also, when you first, when they're finished being exposed, they're still not going to be that really deep, beautiful blue yet, which is another reason why it's a little bit hard to sort of figure out which one, and why you might want to do one at a time, so that your first one you can kind of get a feel for it before you do the second one. But basically what you're going to do is, after the time has passed and you think that it's all good, you're going to take off your items and you'll have some imprint there. Then you're going to need a bucket with water in it. And you're going to take your paper and you're going to carefully dunk it into the bucket and sort of wish it around until the water is going to get kind of that bluey color, and your paper is going to come out a darker blue rather than the kind of gray. And remember, your paper is going to be wet now, so you want to be careful not to rip it, and you're going to put it onto some nice paper towels to then dry. Alright, so here is one side and other side. Some of them have kind of moved already, so I'm going to pull these out. Here is my blueprint attempt. If you guys can see the faint outlines from my markers, and then I did put some like rocks and clovers here. And then here is what my plant side looks like. So I'm going to take these and I'm going to wash them in my bucket of water. And I'm going to put them on this tray with the paper towels. Alright, so I'll show you what they look like after I do that. So here are my cyanotypes. Here's my blueprint version. Hopefully you guys can see that okay. It turned out pretty good. I think that now that I have tried it once, I would be able to like do it a little bit better. Like this up here is a little bit sketchier, and that's definitely because it wasn't as flat, and also the sun was coming in at an angle for both of my prints, and I think that did affect it because the shadows kind of cast a little bit more onto the picture than just the flat images. Also, I had a really cool leaf here, but I did move it partway through, and that definitely messed it up a bit, so you can just barely see that one. But honestly, I think they both ended up really cool, and I do love the really blue color that we got out of these cyanotypes. Of course, as you guys may have noticed in the directions, there is an additional step. So if you had some hydrogen peroxide that you mix with water, you could do a second dunk with these right now. And from what I've read, the hydrogen peroxide and water mixture does make it a little bit more blue, and will also kind of make it a little more color fast, to make it so that it doesn't fade and kind of seals the cyanotype. I don't have any right now, but hopefully by the time that we do this together in person, I will have some for anyone who would like to give that step a try as well. But honestly, these turned out really well even without that step. So what we're going to do is we're going to set these aside to completely dry, and then you can hang them up, or I can hang them up, and when you're finished with yours, you can hang yours up wherever you would like to as well, or make them into cards, or do whatever you would like with your artwork. Thank you guys so much for trying this out with me, and I hope that you enjoyed the power of the sun, creating your own type of photography. All right, everyone, thank you so much for joining me for our sun-powered elementary experiments. Remember, our dates for our in-person this month are going to be September 11th and September 24th. So if those have not yet passed, you can go ahead and sign up to do these activities and crafts in person. Our next topic is going to be in October, where we are going to look into Halloween science. There is a lot of really fun science and chemical reactions and other things that can be put towards decorating for Halloween, although they are also really cool just by themselves. So if you would like to join us for that topic, please look ahead to next month on the 9th and the 22nd. I will, of course, have some more books that you can continue to read on sun power at the end of this. But I think that is everything. So I will say goodbye until next time. Goodbye.